Okay, everybody, this is chapter 5, section 6. You can find the beginning of this chapter. Sorry, hold on. Find the beginning of this chapter on page 325. And this is some stuff that we've kind of already talked about. A new term that's going to be very important for us down the road, but we've talked about isosceles triangles. So let's just go ahead and highlight this. Okay, it's a triangle with at least two sides that are congruent, and the congruent sides are called legs of an isosceles triangle. Okay, and then we've kind of learned that before, or talked about at least, but what happens too is if you've got these two legs that are equal, you've created now two angles here that are called base angles. And kind of in the old days, if the legs were congruent, then the base angles would be congruent, or the angles opposite the legs. So if the two legs have the same measure, then angles 2 and 3 should have the same measure, whatever they might be. And we need to remember too that all the angles in a triangle are going to equal 180. So we're going to play games with you on giving you measurements of angles. You've got to find the rest. Okay, so this probably want to highlight most of this, if not all of this particular paragraph. Base angles is another big term that you need to know. Kind of throw that into your toolbox there. Okay. With that base angles theorem, then we create this same kind of thing we just did. They flip the triangle over, but the legs here are congruent. So therefore, the angles opposite them are going to be congruent, okay? So they're telling me here that they are congruent. They're showing it. You need to show it too, because it's not always going to be able to do that. Now, we haven't done this for a while, but then we get the converse of that theorem. We haven't really hit that too much lately. But the converse of that is saying if the two angles are equal, here, then the opposite sides are going to be equal, so I can show that. Okay. So we can play games back and forth with this one theorem, but it's converse also. All right. So base angles theorem, really important theorem, helping us with isosceles triangles and being able to do some proofs with that. Okay. As we move forward here, we got a proof here. You want to fill in some of this stuff. Okay. Now I want to prove here when we're doing this. I want to prove now. In the past, this whole chapter, we've been proving that triangles are equal to each other by side angle side, or side side side, or hypotenuse leg, whatever. Well, we're still going to do that, but now remember, when I use those things, I'm proving the two triangles are congruent by only using a few pieces of it. Well, now I've proven the triangles are congruent. Now I have to say some of these pieces are equal. So when my last step in my proofs are going to be the CP-CTC thing. We were introduced to that at the beginning of this chapter. Congruent parts of congruent triangles are congruent. Okay. So some math guys like to do this. Congruent parts of congruent triangles are congruent. But CP-CTC is going to be our last step in these, okay? The step before that, we're going to prove the triangles are equal by what we've done so far in chapter 5, okay? So in this particular one, taking a look at this, they're telling me that you've got this triangle LMP, and they're telling me that LM is going to be congruent to LP. So we're going to show that on the picture, okay? they've kind of taken some liberties here. It would have been nice if they had said it. Typically they do, but they're gonna just blatantly say that N is the midpoint of MP because every line should have exactly one midpoint. We've never really talked about that before, okay? So we need to okay, we'll take that for granted. We're not really gonna do the step 2, draw an auxiliary one, but that just means draw a line straight up from that midpoint to the vertex. Now, I gotta make issue with that. How do I know that N is right in the midpoint that's going to go straight to L? That just doesn't make sense to me. But they're taking that liberty. All right, I wouldn't want to do that, but the book is doing that. Okay. So now let's go on. Mn is going to equal Pn because that was the midpoint thing. Okay, so definition of a midpoint. We've got the reflexive property of congruence. Well, this little line here that they made me draw, this auxiliary line, is going to be reflexive to itself. So Ln equals Ln. Okay. Lm is equal to Lp. Well, that was given to me at the very beginning. So given in step 5. So taking a look at that, that was equal to that because of the midpoint. This is equal to itself because of reflection. Are the two triangles I've now created now equal to each other? And they are by SSS. So if I've proven that the triangles are congruent by that, that means everything else in the triangles are equal. And in this case, all the angles are equal. So angle M is equal to angle P by CPCTC down here at the bottom. Okay, so my next to last step is going to be one of these triangle congruencies you've been learning. And my last step now, if I'm trying to prove that parts, angle M and angle P are parts of the triangle, if that's what I'm trying to prove, then I know right off the bat, I know this is going to be my last step, which should be helpful for you in doing a proof. Okay. Okay. In this particular one, they're using the distance formula, but they got a graph, so yeah, we could cheat and we can do the Pythagorean theorem here, okay? We're trying to prove here, are the legs and the angles going to be equal? Okay, so the first thing I need to do is prove if AB is going to be congruent to AC. What's the reason for that? That proves if it's going to be an isosceles triangle. Okay, so I'm just using distance formula to do that. If I did do that, you'll see that I got the same answer. Now I can say that these guys are equal to each other. Okay. Since they're doing that, that means I'm using the base angles theorem. These angles have to be equal to each other. I'm going to remember that a triangle equals 180. They're telling me this vertex angle up here is 70 degrees. So if I subtract it, that means the other two angles together have to add up to 210. So if I go ahead and divide that by 2, I get that this angle down here is 55 degrees, and so should this guy. But that's because the two sides were equal. Okay? All right. Knowing that BC is 8, well, that's just nice. I could say that D is the midpoint and that DC is equal to DB, but I'm not really meaning to do that. Okay? So that's a test question right there. Highlight this example, make sure that you got it. Okay? And then just really quick, this part B down here. Angle C is going to be equal to angle B. That's what I just talked about. Okay. You may have to, in this case, draw this midpoint. Because I proved that they're isosceles, I can say that D is the midpoint, I do create two different triangles now. I might need to do a CPC thing on that if it was approved. Okay. In this particular case, looking at this, they want me to get the measure of this angle here, okay, and this angle here, all right? They're telling me this is 90 degrees. And if I'm gonna think about this, I wanna find out, are these two sides equal to each other? So we're gonna do Pythagorean theorem just really quickly here. If I drew a right angle in there, I went up 3 and I went over 3. So 3 squared plus 3 squared equals a square root of 18. And if I did it here, I went up 3 and over 3. So once again, I get the same thing. So that means that these two sides are equal. So that means the base angles are going to be equal. So I know if this is 90 here, those two other angles have to be 90 together, but I cut it in half. That means that this angle here is going to be 45 degrees, and so is this angle. Okay. All right. Another little theorem we'll get later on, but if I did draw this height here or this reflection, if this is the same length as this, then, and it's, you've got this vertex here, then you could say that the lines are, or the two sides are isosceles that way too, but we haven't got to that yet. Okay, we got these two, the corollary 5.3 and the corollary 5.4. We've done these before. Now we're just making it official. But if the triangle is equilateral, then it's also equiangular. If the triangle is equilateral, then each angle measure is going to be 60. So we've talked about that before, but let's highlight it so you can remember to look at that. Okay. They want me to find angle J up here, okay? So if we take a look at this, trying to get that, they've given me that this side and this side are 12. Now going back to what we just did, if these sides are equal, then it's isosceles, which means that the opposite angles are going to be equal. So this angle has to be 60 degrees also, okay? Now if I know that a triangle equals 180, and those two together are 120, then I subtract that. That means that this angle has to be 60 degrees, which then leads me to the assumption that this side has to be 12 also for that to happen. Okay? So we've kind of done that stuff before. They did down below. Just want to make sure you see that. Okay? All right. Okay, taking a look at this. Once again, if the two sides here are equal, then the angles opposite them, or the base angles, are also equal. If this guy's 60 and these have to be equal, you do this and you get that. Well, I have to divide that by 2. That means that these are going to be 60 degrees also, which tells me that this has to be 5 centimeters too. Okay. Not rocket science stuff we kind of talked about, kind of making a formality now, but let's not overthink that one. Okay. All right. Get this billiards table, the rack to put the balls in before we get going. Now we're assuming it's a isosceles triangle. We're maybe assuming it's equilateral also. Okay. So if we're doing that assumption and we're saying that these two sides here are equal, okay, they're kind of showing me that here and here. Well, I can't really can't really solve that the way it is, but you know, if they're going to be equal and they're and ACB is going to be equal then to this angle down here, kind of doing the base angles thing, okay? If they're going to be equal, then I should be able to say that this is going to be equal, okay, to those. So if I could take this 6x plus 6, I should be able to set it equal to 60 degrees, because 6x plus 6 is this angle down here, okay? So that's going to be 60. I can subtract 6 from both sides and get 6x equals 54, and divide both sides by 6, I get 9. Okay. Okay, so if I get that, if that's 60 and this would have to be 60 also, that means this is 60. So that means that this side and this side should be the same now. Okay, so I should be able to take those two and set them equal to each other. So they do that kind of down below. And I'll solve this for y. So I'm going to subtract 2y from both sides. Get that. I'm going to add 2 to both sides. I get this. And I'm going to divide by 2. I get y is 2. Okay. So this angle back here kind of made a mess of it. Sorry. This was an angle back here, okay? And because these two sides are equal, then this angle here has to be equal to that angle there. They told me that was 60. So that's why we were able to do this, okay? All right. Okay, they give me ever been to Paris and went to the Louvre, taking a look at the entrance to the museum is this big old pyramid, okay? And what they're doing here is they're saying it's an isosceles one, so that means that this side right here should be equal to this over here. So I should be able to set those equal to each other. I know they do this below. You get that, okay? So by doing that, I can go and add 5 to both sides and get 120. I can divide both sides by 4 and get 30. Okay. Now, if these two sides are equal, that means this angle and that angle would be equal. But if the sides are all equal, then I should be able to set that 2x equal to 60 degrees. Okay. So if I divide both sides by 2, I'm going to get x is 30. Okay. All right. If you ever go to Paris, you got to go there because it's pretty cool. All right. Okay, so that takes us to the end of our notes. Please make sure you're doing the classwork. Please make sure you're getting some help. Big thing here too is to make sure that you're getting CPCTC when you're doing your proofs should be the last step, or recognize, am I proving that triangles are congruent or just pieces of them? If it's just pieces, CPCTC has to be the last step, and one of the triangle congruencies has to be in the step before that. Okay, thanks.